In this question, we have y equals 2x squared plus 12x minus 11. It is in standard form, and we are being asked to write it in vertex form. Notice how this looks a little bit different from the questions we saw last week because there is a number in front of x squared. In the questions we looked at last week, this number was a 1, so we were able to just follow those steps without really having to deal with anything in front of the x squared. Now there is something there. So what we're going to do is take a look at the fact that this is standard form, this is vertex form. The a that's in both of them is actually the same number. So what we have to do to get rid of the number in front of x squared is we actually have to factor it out. So I'm going to factor out the 2, so make sure you review common factoring before you get to this part. I'm going to factor out the 2 to get rid of it so it's not beside the x squared. And when I do that, I'm only going to factor it out of the first 2 terms. So I'm going to bring the 2 to the front out of the first 2 terms. And what I have left inside the brackets, divide by 2, divide by 2. What I have left inside the brackets, 2x squared divided by 2 is just x squared. And then 12x divided by 2 is 6x minus 11. This stays the same. I didn't touch it. I only factored it out of the first 2 terms. Now I'm going to continue the steps that we saw last week. On the side, I'm going to write b over 2 squared. Only now my b isn't this number in the middle. I factored it out the 2 from it, so what I'm left with is the 6. So actually my b is this 6 right here. Six divided by 2 is 3, and 3 squared is 9. So everything else is going to stay the same, except after that b value that I had just used to calculate, I'm going to add plus 9 minus 9. And then everything else stays the same. Okay, so far the steps are similar to last week. The only difference is that I had to factor out the number that was beside x squared, and I have values inside the brackets now. It's not all in one expression. So you will notice when you look at this that x squared plus 6x plus 9, that is my perfect square trinomial. This is what I'm going to factor into my binomial that's being squared. But I have this 9 over here. I don't need it in the brackets. I want to get rid of the 9. It's not part of it. So I'm going to take the 9 out of the brackets. And notice that there's a 2 in the front here. So that means when I take the 9 out of the brackets, I have to multiply it by 2. So everything stays the same. X squared, so 2 and then x squared plus 6x plus 9 is in brackets. This number I'm taking out of the brackets, and before I do that, I multiply by the 2 because of the distributive property. So 2 times negative 9 is negative 18 minus 11. Okay, so from this step to here, I've just gotten this out of the brackets and times it by 2 before I did that. So here I have my perfect square trinomial. So if it helps, I noticed a lot of you last week were writing it like this. 2x squared plus 6x plus 3 squared. If you need that in between step, you can do that, but you don't have to do this every time. And then negative 18 minus 11, they're both negative, which means we're going further into the negative side of the number line. So that's negative 29. And I can factor this as a perfect square trinomial. X, so the base here, this is a plus sign. This is a 3. Squared minus 29. And there we have vertex form. And I can see that my vertex is my HK. So here my H opposite, so -3. And my K is -29. Next example. Y equals -x² minus 5x plus 1. Again, the number in front of x² is not 1. There's a negative sign in front of it. So it's kind of like there's a -1 right here. And that's what I'm going to factor out. So I'm going to bring the negative to the front of the bracket, and I'm going to divide it out of the first two terms. So -1 divided by -1. And what I'm left with, so these ones cancel out, and I'm left with x². -5x divided by -1. Negative divided by negative is positive. And this stays the same. So this doesn't change. Okay, very important to note this. Negative divided by negative is positive. That's going to happen quite a lot in your practice questions and when we get to problem solving. Okay, so now on the side, I'm going to do my calculations for b over 2 squared. In this case, my b is +5 over 2 squared, though really it doesn't make a difference because positive or negative, it's going to get squared and become positive. 5 divided by 2 is 2.5 squared, and 2.5 squared is 6.25. So I have a decimal this time. So I'm going to write everything the same way, except after the 5x, I'm going to write plus 6.25 minus 6.25. That's going to be inside the brackets, and then outside the brackets, I still have +1. I have my perfect square trinomial right here. Because that's what these steps are going to give you, even though we can't always tell just by looking at this number here when it's a decimal, but because of these steps, I squared something to get this number, which means it has to be a perfect square. So I want to get rid of the minus 6.25, so I'm going to take it outside of the brackets, and before I do that, I have to multiply it by the number at the front, so I'm going to multiply it by -1. So I'm left with -x² plus 5x plus 6.25. -6.25 times -1. Negative times negative is positive. You'll notice that here I have my perfect square trinomial. I'm going to do this step again, even though you don't have to. I'm going to write 6.25 as a perfect as a power, and I can see it up here. So 6.25 is the same as 2.5 squared. Or you can put the square root of 6.25 in your calculator, but you have it up here. Plus, I can simplify this. 6.25 plus 1 is 7.25. Final step, negative. I'm going to factor this. So the base, this is my A, plus my B, and the whole thing is squared. And there's my vertex form. My vertex here is, it's the opposite here, so -2.5 and 7.25. That one's positive. Last example. Here we have a decimal in front of the x². Our question is y equals 0.5 x² plus 3x minus 10. It doesn't matter what is in front of the x². We are always factoring out that value. So this is always going to be your a at the front. So I'm always going to factor it out of the first two terms. So So I'm going to divide it out of the first two terms. When I divide it out of the first term, you will always end up with x squared. So in the brackets, it'll always look like it did last week. It'll just say x squared. And then your second will be some other value. So 3x divided by 0.5 is 6x minus 10. So I'm going to calculate my b over 2 squared on the side. In this case, my b is 6 again, like in the first example. So 6 divided by 2 squared is equal to 3 squared is equal to 9. So I'm going to write everything the same way as it is in the last line. But I'm going to add plus 9 minus 9 after the 6. And then everything else, bracket minus 10. So I have 0.5, and then in brackets x squared plus 6x plus 9 minus 9, bracket minus 10. Looking at it, my perfect square trinomial is right here. So I need to get rid of the minus 9. I'm going to bring it outside of the brackets. Before I do that distributive property, I have to multiply it by 0.5. So I'm going to copy everything the same way. And you can even do this in one step at this point. So I have x squared plus 6x. I can write 9 as a power. So 9 is the same as 3 squared. Negative 9 times 0.5 is, so negative times positive is negative. 9 times 0.5 is 18. So negative 18 minus 10. And then you can do this in one step. So I have my a at the front, and I can factor this. X, that's positive, so plus. My b, which is 3, squared. Negative 18 minus 10 is negative 28. So there I have my vertex form. I have my a, my h, and my k values. And by looking at it, I can identify that the vertex is, so the opposite here, so negative 3, comma, negative 28. That's it.